Hey guys, it's Miss Johnson here, and I'm here to bring us our notes video for 7.3, which is square root functions and inequality. We want to start graphing these square root functions today. Up at the top, example 1 says, consider the function f of x is equal to x squared. The first thing we want to do is find the inverse of that. So remember from our notes from yesterday, to find the inverse, I need to switch the x with the y. So what I'm going to do first is I'm going to put x in the y position, and then I'm going to put my f of x in the x position, but now I call it the inverse. And I'm squaring that whole thing. Sorry, my pen is not really working out here. So I have the inverse of x squared. Now, we also know that we need to solve for that. So in order to solve for the inverse of x squared, I need to take the square root. But remember, whatever I do to the right, I have to do to the left. So I end up with the square root of x equaling the inverse of x. Okay. Then the second part of that question says graph both of these on the same coordinate plane. So I'm going to graph x squared and the inverse of x on the same coordinate plane, which is the square root of x. Okay, so if I graph x squared, I'll put that one in red. So I'm going to graph x squared. Now you can use your graphing calculator to help you with this. Remember, you put those equations in the y equals menu and see what they look like. If I graph x squared, I end up with a parabola, and most of us are familiar with parabolas. We remember what they look like. I'd have an opening up parabola here. I'd have points at 1, 1. I'd have points at 2, 1, 2, 3, 4. And I can just put my points on the coordinate plane there, and 2, 1, 2, 3, 4, and I'd have a parabola that opens up like this. Okay, that U-shaped graph. Now, when I put the inverse of x, I'll put that one in green like I have over here. When I put the inverse of x, which is the square root of x on the coordinate plane, I end up with the parabola, kind of turned on its side. Now remember, we learned yesterday that the inverse functions are reflected over the line x equals y. So if I reflect that over the line x equals y, oops, held that down a little too long there, I need a pen back. I'm still at a 0.11, but then I kind of go off to 4, 2. I'm switching the x and the y. So 1, 2, 3, 4, up 2. And it looks like this. Now, if you put this on your graphing calculator, you'll notice that it only gives you the positive version there. It only gives you the positive y values. Now, the reason for that is if we took the whole parabola and I graphed it down here, now all of a sudden we don't have a function. For those of you that remember, the function, in order for something to be a function, it needs to pass the vertical line test, which if we put those negative y values on, it wouldn't pass. So these negative values are out, and I'm really only looking at the positive values there. That's what square root functions look like. This piece right here. Okay, you're going to have some sort of curving line, and most of the time they're going to be positive y values, unless for some reason we have a negative in front. Let's take a look at example 2. It says graph the equation y equals the square root of x plus 2, state the domain and the range, and the x and y intercepts. So I'm just going to plug these values in. When I plug in the square root, or when I plug in -3 for x, I would have an undefined value there, because if I plugged that in, I'd have the square root of -3 plus 2, which is equal to the square root of -1. That's undefined. That's an imaginary number. We don't know how to graph that, so we actually don't have a value for that one. Now we're going to go ahead and plug all the rest of these in, so that one's undefined. When we plug the rest of these in, if I plug in -2, then I have 0 underneath that radical, and the square root of 0 is just going to be 0 there. If I plug in a -1, then I get 1. If I plug in a 0, 0 plus 2 is 2, and the square root of 2 is approximately 1.4. So that's the y value I'm looking at there. If I plug in a 1, then I'm looking at the square root of 3, because 1 plus 2 equals 3. So then square root of 3 is approximately 1.7. So those are the values that I'm looking at graphing on that coordinate plane. So let's just go ahead and plot those points there. When I plot those points, I end up with, -3, I don't have a point. So -2 is the first point that I have, -2 and 0. so right about there. Then at -1, I'm up at +1. At -2, or I'm sorry, at 0, I'm at about 1.4, so almost halfway. And then at 1, I'm at about 1.7, so like about 3/4 of the way up to the 2. That's what my function looks like. When I connect those, it's going to look like that, and it's going to go off in that direction. Now we want to look at those things listed below. The x-intercept and y-intercept are pretty easy to find. The x-intercept is where it crosses the x-axis. So where it crosses the x-axis is at -2, 0. Or in other words, it's where the y value is 0. And then the y-intercept is the reverse, where the x value is 0. And in this case, where the x value is 0 is at the square root of 2. So that one is 0, comma, square root of 2. And then domain and range. This one is a little bit trickier for us. When we look at the domain, we're looking at all of the x values. So if you don't remember what that looks like, that's the x values of the graph. So when I look at the x values, my lowest x value that I can have is -2. Because when we had -3, it was an undefined value. So all of my x values have to be greater than or equal to -2. That's going to be my domain. Then the range, remember that range is all of the y values. So for range, I'm looking at the y values. And for range here, my lowest y value is 0. So my range values are all going to be greater than or equal to 0. Okay, so that's what that graph looks like, and that's how we find all of that. Now, if we wanted to find the domain of a function, okay, these are some math rules to live by. This chapter especially is where we're going to need to remember some of these things. These are just some function or some rules that we've learned in the past, but we need to keep them in mind for this chapter. We're not allowed to divide by 0. We don't have a square root of a negative number. It gives us an imaginary, and that's not part of a function. We can't leave any negative exponents in our simplified answer. We've looked at that before. We can't have radicals in the denominator and can't have fractional exponents in the denominator. So those are just some things that we've seen before, but they're going to come back to us this chapter. To find the domain of a function, we need to think about this. The radicand has to be greater than or equal to 0. That word radicand is what's underneath the radical. Everything that's underneath the radical is part of the radicand. Okay, so what we do is we set the radicand greater than or equal to 0 and solve for x. That's how we find the domain. Okay, that's how we're going to find the domain of that. So if I take a look at some examples here, let's say I have the function y is equal to the square root of 4x plus 2. So I'm going to take what's underneath the radical, that 4x plus 2, and I'm going to set that greater than or equal to 0. And this is going to give me the domain here. So solve for x now. When I solve for x, I need to subtract the 2. So I have 4x is greater than or equal to -2. And then I'm going to divide by 4. And when I divide by 4, I end up with x is greater than or equal to -1/2 when that's reduced. So that's my domain for that function. If I take a look at the second part or the second example there, I want to again set just the radicand greater than or equal to 0, just the radicand. I don't need to worry about this +4 for the domain. That's going to come into play when I look at the range, but for the domain, I'm only looking at what's underneath. So again, I'll take the 2x minus 3, set that greater than or equal to 0. I want you to go ahead and finish solving this and see if you can tell me what the domain of that function would be. Let's take a look at finding the range. If we wanted to find the range of a square root function, that means that we need to now take a look at the starting point. Okay, to find the range of a square root function, we need to look at the number that's behind the radical. Okay, so what happens when we are outside of that radical? That c is going to be our domain. Okay, so in this case, if I look at that one, we already found the domain for y equals the 4x plus 2. For the range, there's nothing here. There's nothing behind it. It's like saying plus 0. So when we have plus 0 and there's nothing behind it, that means that it's just y is greater than or equal to 0. So for that first one, the range would be y is greater than or equal to 0, that first example. For the second example, we did have something behind it. There was a number behind it. And when there is a number behind it, oops, undo that. Wanted my arrow there. When there is a number behind it, it's just whatever that number is. So I'm going to take that number, and that's going to be my range. My range is going to be y, in this case, is greater than or equal to positive 4. Okay, so that's my domain and range there. All right, that's going to conclude our video for today. Thanks for listening, and we will come back and do the rest of our notes tomorrow. Have a great evening.